We're going to start on time, late. Again, for the benefit of the webinar audience, just to let everyone know that we did experience some technical difficulties in the realm. We had a fire alarm that put everyone out into the parking lot for 20 minutes. It took us a little while to get started again, but we're ready to roll. That's why we're starting 15 minutes late. So I welcome everyone on the webinar audience. We have almost 200 people signed in right now, which I think is pretty good, as well as welcoming the people who braved the cold weather, chilly compared to what we've had a couple weeks ago, to get into Trenton and also be in the audience. So next slide, please. How are we doing there, Joe? There we go. What I wanted to do for the benefit of the people who aren't familiar with the technical guidance development for the site remediation program, just go over quickly what we do. Most of the people that I see in this room, as well as that I saw logged into the webinar, are already aware of this, but for those who are not, we're going to go over it quickly. Next slide. Just wanted to give you an idea of what happens in the technical guidance committees. They're composed of about 5 DEP staff, 7 stakeholders, occasionally depending upon performance. I guess how it goes. Some people have dropped out. Not too many. We probably lost maybe 2 out of all of our committees. But the idea is to get a well-rounded perspective across the table when everyone meets, and I think it's worked out very well when we have 5 DEP staff and 7 outside stakeholders. The topics have been selected via meetings, major meetings we've had here at 401 in the public hearing room. We started actually the first round in fall of 2010, and then the second round in the summer of 2012. We worked actually pretty hard to whittle down a lot of the topics, and we think that the ones that we do have are pertinent and useful to both DEP and the outside stakeholders. Our documents consider, once they are issued draft, there is an internal as well as an external review process. The internal review process goes through the Assistant Commissioner's Office, all DEP managers, which is bureau chiefs, directors, assistant directors, as well as DEP staff have the ability to also participate and conduct a review upon their request. We have up here average of about 24 months to complete a document. That's actually a little bit longer. A lot of that, people are like, why does it take 2 years almost to complete a document? Well, if you're on one of those committees, you would understand it. It's very difficult. People actually are doing this on a volunteer basis, although we think the work's very important. Everyone does have other jobs, DEP staff as well as outside stakeholders, and to get a lot of the work writing tasks completed in a timely manner is difficult sometimes. So the idea is that it does take a little while to get those documents done, but in my experience, almost every document, I'd say every document that we have out has been done well, and they are of high quality. In addition to that, we do train on these documents. That's what today's training session is about. In addition to that, all the final documents are posted on the SRP website, and that is at this address that's up on the screen, and that's just the guidance library within the SRP website. Next slide, please. This is just to remind you of the Round 1 technical guidance committees and the topics that they addressed. All these documents, again, are completed and available on the guidance website. Next slide. Next slide. There we are. Round 2. This is the current technical guidance committees, the Round 2 guidance committees. Capping, I would give them credit. They're the only one that has finished the document so far, so congratulations to the capping committee. 2 are done. Number 3, it says issued draft. Actually, we caught this probably in the middle of editing. That is both number 1, offsite source, as well as number 3, historic pesticides have issued their documents draft, and they are currently addressing comments. Once the comments are addressed, all of our documents, we issue both the document as final as well as a response to comments document, which is an Excel spreadsheet. It takes a little bit extra work, but we think it's important to let those people know that took the time to comment on our document that we actually considered those comments, and we issue a response so that they know what our position was, whether the comment was accepted or not. As far as that's only major comments, ones that have substance, not just editorial comments. We don't list in that. Just wanted to also point out number 7 and 8, child care centers and catastrophic events. Those were actually added later on at the request of some of our stakeholders, as well as DEP's management, that it was pertinent and important to get that kind of information out there and clarifications. So those child care centers was added after a public meeting, or a meeting that we had here, training on child care centers, and we realized additional guidance was needed. They are working hard at getting that completed. Catastrophic events was added in response to Sandy and the impact on all of our sites. We realized that it would be important for us to issue a guidance document to help us prepare, plan, and respond to those kinds of events, not just storms, but also it could be major events where we have power outages, that kind of thing. So I think that document will be useful. Next slide, please, Joe. So I just wanted to remind everyone that today's training session on the capping guidance is really an overview. So if you came here to learn everything about the capping guidance and are planning not to actually look at it, I would recommend that you actually look at the document. There's a lot of technical, detailed information within that document. What we do here is try to give you a flavor for what's in the document with our two presenters, and I think they do an excellent job at that. But again, we would point you to looking at the technical guidance, which is available on our website for additional information. Next slide, Joe. So what I wanted to do today, we've had a lot of requests from the outside community saying that, you know, we participate in the webinars. It would be great if we could get CECs for webinar participation. That's not easy from a tracking standpoint. We have worked with the LSRP licensing board in trying to obtain permission and approval to conduct webinars and get CECs for that. Just wanted to let you know, for the webinar audience today, you guys are our test model because what we are trying to do, we're going to try to see if it's possible to monitor and make sure people are actually at their computers paying attention, not just logging in and then going and doing other work, because we really can't track that. We track people within this room. They sign in, they sign out. We know that they were here, and they're all paying attention, I can tell, within the room today. So what we're doing at today's, as a test model, at random intervals, we're going to issue test questions that will appear for the webinar audience to answer. They must answer the question. Now, we're not really worried whether it's correct or not, although it would be great if it was. That means you're actually paying attention. But this will indicate to us that you are actually at the terminal, you are paying attention. The questions are very simple. You should be able to handle them. And in order to gain CECs in the future, webinar audiences will have to respond to those questions. They are random, so you don't know when they're coming up. So hopefully you will be at your terminal when they do. One problem we have, and we haven't figured out a way to resolve this, is that we can't issue CECs in situations where people have a large conference room maybe. They log into the webinar and they're broadcasting that within the conference room with maybe 10 or 15 people. Although that's a very effective and efficient way for people to use our webinars and to train on that, there's really no way for us to document the number of people in the room and the fact that they were there for the entire training session. The LSRP licensing board, we're working. We haven't really resolved or come up with a solution to this. Perhaps that will happen in the future, but we're taking baby steps, and this is our first step to try to get CECs for our audience. Okay, Joe, next slide. So this is what will pop up for the webinar audience. Everyone in here is free to also participate. I think you can handle the first question. You might be able to figure it out. That might be true. I would think it was true. But this is the slide. It's totally different than all of our other slides, so that's readily recognizable. We will ask everyone to answer that question and indicate that they are actually participating in the webinar. And so we would hope that everyone in the webinar today, please make sure you do this. You would be setting yourselves up for possible ability to get CECs in the future. Next slide, Joe. Great, thank you so much. Right now we would ask Ted Toscas to come up before we start our training presentation and just give us a little bit of an update on the LSRPA. Ted? Welcome to use either one.
Oh. Okay, so we'll make it up as we go. I'm Ted Toscas from the LSRPA.
Sorry, you can advance your slide yourself.
Great, thank you. Thanks. We're very happy to be working with the DEP to present this session. Those of you who got your licenses on the first round of licensing, you will know, you would have seen the listserv announcements that says that you got to start thinking about doing your continued education credit count, because one of the things you're going to have to do as part of your license renewal will be to submit evidence of having fulfilled your continued education requirements. The slide here spells out what those requirements are. let's see, up, down, on the right. This is some of the more nitty-gritty of what counts for an hour of educational credit. It's all it's on the slide, and it's also spelled on the board website. We would like to thank our various sponsors whose general contribution is making things like the online registration and the admin staff for tracking people in and out and issuing the credits possible. And with that, I would like to remind you, I think we lost a couple of slides here, that the LSRPA is sponsoring various training events. You can go to the website and see what's coming up. And obviously all those classes will give you a number of CECs, whether they're technical or regulatory or otherwise. And with that, I'll turn it back over to Greg for the main portion of the training. Thank you.
Thanks, Ted. Actually, this is George. Just wanted to remind everyone in the audience, due to the webinar audience, it's very important when we do have questions, we'll be running a mic around. Please, I ask for your patience in waiting for that microphone so that the webinar audience, as well as people in the room, can hear what that question is. And then the answers, we ask for all the presenters to make sure that they're at a mic when they are responding. So right now, as far as the agenda, just to remind everyone, first we'll have up Greg Newman. He's going to give us an introduction and an overview of the document. Then Howard Nichols will be coming up and talking a little bit about two types of caps, and that's permeable and semi-permeable. And then we're going to have Greg come back up at the end and talk about sediment caps. So with that, and then we'll also have questions after each one of those sections. So Greg?
Okay, thank you very much, George. Good morning, everybody. Before I dive into the technical aspects of the document, I just wanted to give everyone a brief introduction to our capping committee. Next slide, please. As you can see here, our capping committee consisted of a total of 12 members. We had 6 members from the DEP staff. Terry Sugahara served as our chairperson. We had Paul Sanders, who was our contaminant transport modeling expert. We had Greg Giles, who was a geologist. Mike Burlingame was a geotechnical engineer, and we had Kathy Coons, who served as our oversight representative. On the external stakeholder side of things, we had Steve Kronowski from the Chemistry Council of New Jersey. We had Ken Hart, Howard Nichols, Alana Seelman, and Ted Toscos representing the environmental consulting industry. And lastly, you had George Vallone from Hoboken Brownstone, who was also a member of the New Jersey Builders Association who represented the development perspective. So as you can see, our committee consisted of a diverse group of stakeholders with expertise in various environmental disciplines related to capping, and it really did result in the creation of both a strong and well-represented guidance document. Next slide. So just to help set the stage here for the presentation, I just wanted to go over the general purpose of the guidance document. First and foremost, we wanted to actually define what a cap is. We covered 3 broad categories of cap types, namely low permeable caps and permeable caps, which occur in an upland setting, as well as sediment caps, which occur in an aquatic environment. As part of the introduction that I'll be going over, I wanted to discuss some factors and limitations to consider when selecting a cap, and that applies broadly to all caps. And the focus of the guidance document is really to help you determine which caps are most favorable based on the site-specific remedial issues posed by your particular site. This guidance is not intended to determine if capping should be selected as a remedy versus other types of remedies, such as excavation and whatnot. This guidance was really developed for the user who has already determined that a cap is a viable remedy, and this guidance is developed to help you identify which particular cap type might be best suited for your site. Next slide, please. To help define the scope of the guidance document, the committee established several assumptions that I'd like to go over. We assume that the RI process is complete. You know, you went through the PA and SI and remedial investigation process as well as filling out your receptor evaluation form. In terms of containment, which we consider the lateral movement of contamination, that particular movement is really not the focus of the guidance document. A good example of the lateral movement of contamination and a remedial option to address that would be like a slurry wall. This guidance really focuses on the vertical plane, you know, so that the capping remedy in that instance would address direct contact concerns. As with any other remedy, a lot of site-specific information needs to be available, and we're assuming that that's been collected and is accurate. A lot of professional judgment will come into play for your site in determining what information is actually warranted. You know, we're going to assume that delineation is complete. We're going to assume that the geotechnical properties associated with the native soils has been established. You know, can your soil actually support the load of a cap? These are some of the things that we're going to assume the reader has actually accomplished. Lastly, I'd like to note that all capping remedies must comply with Section 5.1 of the Tech Regs, which basically states that remediation of free and residual product is required to the extent practicable, and if not practicable, free product and residual product should be contained or removed. Next slide. Okay, so in the simplest of terms, a cap is a barrier located over contaminated media that mitigates exposure. All capping remedies must be protective of human health and the environment. A cap does not decrease or actually reduce contaminant concentrations, at least in the short term. Again, caps are primarily effective by actually mitigating exposure. As you can see from the pictures here, caps are commonly used as remedies with a variety of end uses. Asphalt caps are typically used as parking lots and roadways. Concrete caps are used as building slabs and foundations, and are also used where heavy-duty vehicle usage is anticipated. Soil caps might be warranted when a cap should be permeable. Also, soil caps can be vegetated. And lastly, as you can see in the picture on the right, caps are often used as landfill remedies. Next slide, please. Okay, I just want to touch on some regulatory requirements and permitting issues that may or may not be associated with caps, again, depending on site specifics. A cap is an engineering control and does require a soil remediation permit pursuant to ARCs, and I'll touch a little bit more on this later. There are various permits or rules that may be required when you construct a cap, and again, they're going to be very site-specific. Some of these permits or rules may extend actually outside of the NJDEP SRP program. If you were to be capping PCBs, there might be federal TSCA rules that you would have to follow. If your cap was going to infringe on ecological habitat or deal with stormwater issues that actually discharge to surface water bodies via outfalls, you might have to deal with an Army Corps of Engineer nationwide permit. If your cap was going to include the stabilization of bank along a major waterway, again, Army Corps of Engineer permit might be required. If your cap was to extend into freshwater wetlands or be part of a waterfront development project or perhaps extend into a floodplain, you're going to need these types of permits from our land use regulation program. On the local side, you might need actually local or county permits for cap construction. An example of this would be a soil conservation permit. Obviously, the needs for these types of permits is very site-specific, but the tech regs require at Section 1.1b2 that it's the investigator's responsibility to ensure compliance with all federal, state, and local statute or regulations. Next slide, please. Okay, on to administrative requirements. If any of you are familiar with CAPS, you know, there are a host of administrative requirements that you're going to have to follow. Again, the DEP considers CAPS as engineering controls. And a deed notice would be required with any cap since they're covering contamination that's left in place that exceeds our unrestricted use standards. I'm not going to go into the details of a deed notice, but they can be found in our ARCS document in section C7. And as I mentioned earlier, capping remedies will require that a soil remediation permit will be obtained. And there are a host of specifications that are required for those, and they can be found in our guidance document titled Remedial Action Permits for Soils Guidance, which was issued in 2010. Next slide, please. As many of you are probably aware, the department has issued guidance on presumptive remedies and may be wondering how this particular guidance dovetails with the presumptive remedy guidance. The bottom line is that it does not. The presumptive and alternative remedy guidance addresses remedial actions initiated after May 7, 2010, where new construction is proposed for residential purposes, licensed child care centers, public, private, and charter schools. Remedial actions at these types of uses must be to an unrestricted use, presumptive use, or alternative remedy use pursuant to the above guidance. This capping guidance should not be used to circumvent the presumptive remedy guidance. The intent of this guidance is to cover receptor groups not covered by the presumptive remedy guidance document. Next slide. Okay, some technical factors that you should consider for a capping remedy. Obviously, some of these are pretty obvious, but you're going to have to understand your contaminant properties. What type of contaminants are you dealing with? Are you dealing with mobile contaminants such as VOCs? Or are you dealing with contaminants that have properties that would allow them to stick to and tightly bind to the soil, such as PAHs or PCBs? What's their distribution? What's going to be the extent of your cap? What are the properties of the native soil? Is your native soil physically stable? Factors such as particle grain size and the organic content, may influence the contaminant mobility of your site. What's the actual bearing capacity of your soil? Can it support a foot of concrete? A geotechnical investigation would be required to answer some of those questions. If your cap is going to be on a slope, are you going to consider veneer stability? We don't want your cap falling off the side of the hill. Hydrology is also another factor you're going to have to consider. Will your cap come in contact with the water table? Do you have to take into account seasonal fluctuations of the water table? If you install an impervious cap, how are you going to handle stormwater? Again, these are some of the issues that you're going to have to handle. Next slide. Regulatory factors. What type of receptors are utilizing your site? Your cap design needs to include an assessment of all exposure pathways and receptors. And this is typically accomplished through the completion of a conceptual site model, which all sites should have. The primary exposure pathways that you're going to have to deal with, again, no surprise here, dermal contact, ingestion, and inhalation. Not every site will have all of these exposure pathways associated with it. However, the investigator must evaluate all pathways to ensure that the cap is protective. Environmentally sensitive natural resources, important topic here. Does your site have wetlands or streams or marshes or any other type of habitat that meet the definition of an ESNR? These require careful evaluation and, again, adherence to potentially regulations outside of SRP, such as our land use regulation program. If you have contaminants of concern in the environmentally sensitive natural resource, the quick answer is not always that you can cap them. We don't want people running out there and just slapping a cap out onto a wetland for minimal exceedances of a screening criteria. You would have to evaluate your contaminants of concern pursuant to 1.16 and 4.8, as well as our ecological evaluation technical guidance document. I'd also like to make people aware that if you have historic fill on your site that ends up migrating into a environmentally sensitive natural resource, that capping is not an assumed remedy for historic fill contamination. Okay, we don't want to really see asphalt caps going down into our wetland. If a remedial action is required in a wetland, it would likely consist of perhaps excavation, or if capping is an appropriate remedy, it would likely be a soil cap that would be revegetated revegetated with native plant species to allow the receptors to actually use that area once remediation takes place. Current and future land use is very important to consider when implementing a capping remedy. Any change in use should trigger a reassessment of the cap's ability to remain protective of that future use. Next slide.
Okay, here's where we test the webinar's audiences, whether they're paying attention. We got that up. And why they're doing that, why the webinar audience is, we're taking a poll. I think we're going to also take a poll within the audience here. You guys can participate too, just to help everyone out. So as far as the capping guidance may not be used to, what's the rest of it say, do we know? Thank you, Bridget. You are awesome. How many people think that's true? How many think it's false? All right. Just want to let the webinar audience know that everyone in the room was paying attention. So we'll see how well you do. We're going to give you probably another 10 seconds or so to respond. We have 78% voting, 79% are voting. All right. Keep it up there. We want 100%. That would be awesome. Except for Joe. Joe's logged in. Joe, you don't have to answer, so we get 99. That's okay. Joe said he's logged in on my computer, so he put the wrong answer in. Okay, that was 1 minute. Give it a couple more seconds. Okay, let's stop that, Joe, and then we'll continue on with the presentation. I thank everyone in the room for their patience. This may be how we're going to do it in the future, but I think it will be worthwhile as far as our training abilities. So, next slide when you get a chance, Joe. And thanks, Greg.
All right, this last slide of my presentation covers a few factors that the responsible party should consider. Very recently, both the federal and state environmental agencies are promoting the use of green and sustainable remedies. We actually promote that as part of the tech regs at Section 1.9, and the United States Environmental Protection Agency has actually issued a clean and green policy directive. So capping remedies should be included, in terms of an evaluation of whether or not that's a green and sustainable remedy. Some factors that you should consider in evaluating that is, will your capping remedy support human and ecological receptor use and reuse at the site? Does your capping remedy actually minimize impacts to water quality? Does your capping remedy potentially reduce air emissions compared to other remedies? Does your capping remedy minimize water use and waste production? And finally, does your capping remedy conserve natural resources and energy? So these are some of the things you can think about when evaluating a capping remedy for your site in terms of being green and clean. The cost of your cap. Obviously, costs associated with material, labor, engineering design to actually put the cap in place are, again, obvious costs. But you should also consider costs that may not be so obvious when comparing a capping remedy to other alternatives. There's a cost associated with deed notices, as well as biennial certifications. Again, a cap isn't a permanent remedy, so it's going to require monitoring and maintenance, and that's going to be needed for as long as the contaminants of concern remain at levels above the standards. Additional costs are associated with remedial funding sources and financial insurance. So again, there are costs that go beyond the simple construction of the cap. Lastly, I'd like to cover community acceptance and aesthetics. This is obviously not a requirement, but something that's gaining a lot of traction in terms of remedial actions. If, let's say, you had an industrial site with low levels of contamination that extended to a bunch of properties where some residents lived, yes, an asphalt cap would most certainly be suitable. But maybe a 1-foot soil cap that became revegetated would be more aesthetically pleasing to the residences. Involving community stakeholders early on in the process and getting their input is an important part of the process that all remedies should consider. So that concludes my portion of the introduction. Are there any particular questions?
We'll take questions at this time. Do we have any questions in the room? Okay, seeing none. Joe, do we have any from the webinar audience? Okay, Joe, just open up the questions from the webinar audience. We'll wait a second if there are any. Otherwise, we'll move on in a couple seconds here. And then we'll have Howard Nichols come up and talk about permeable and semi-permeable caps. And Howard, if you could just give people just a little brief introduction for yourself. Okay, let's Joe. And then we still have others at the end. Thank you very much, Greg. Howard?
Good morning, everybody. I'm Howard Nichols with TRC Environmental. I'll be talking about a couple classes of cap types for you this morning. Go to the next slide, please. The guidance document covers three main groups of caps: low permeability, permeable, and sediment caps. I'll be discussing the low permeability caps and the permeable ones, and then the presentation will go back to Greg Newman for the sediment caps. Next slide, please. Low permeability caps is one specific type of cap. It's really intended to minimize or prevent the transmission of water or vapors through the capping material. Water transmission is just what it sounds like. You're stopping water from coming through the cap and coming in contact with the contaminated soil underneath it. Vapor transmission works in the opposite direction. You're looking to stop contaminated vapors migrating from the underlying strata through the cap and into the overlying air. One thing, there are many things to consider with low permeability caps. You're very likely going to have changes in your water balance at the site. Low permeability cap is stopping water from coming in, so recharge will be minimized. Water transmission is typically measured in centimeters per second. 10 to the minus fifth centimeters per second would be a spec for a low permeability cap. Vapor transmission caps, vapor transmission is measured in perms. It's an ASTM standard, I believe. Next slide, please. The components of a low permeability cap typically include a soil protection layer. It's not involved in every low permeability cap. The soil protection layer can promote runoff, vegetative growth, help control erosion as well. All low permeability caps will have a low permeability layer. It's the primary component of the cap. It could be constructed of many different materials. Compacted clay can be used, geomembranes, geosynthetic clay liners, asphalt, concrete. We'll talk about another version later that people might know as a liquid boot. Geotextiles can often be incorporated into a low permeability cap. They can be placed above or below the low permeability unit, usually as protection or identification. Next slide, please. Okay. When you're designing a cap, there's many things to consider, and this guidance. Sorry. How's this? Does this sound better? All right, good. There's many things to consider when you're designing a low permeability cap. The guidance document provides a pretty good overview, but is not comprehensive. You should consult with an expert while designing the cap. But when designing, you should consider the effectiveness of the cap. Is it going to meet the goals that you've set out? Will it limit the water migration? Will it limit vapor migration? Will it also protect against direct contact? The compatibility of the cap with the current and future planned site uses, surrounding land uses, and the nature and the extent of the contaminants. The duration of the cap is something else that should be considered. How long is the contamination going to remain in place, and how long you're anticipating your capping material to remain in place? Stormwater management, like I mentioned before, is likely going to change. Water's not going to be percolating into this cap and recharging the local aquifer. It's going to run off, which could cause erosion, could cause flooding at adjacent sites if you don't manage your stormwater properly. Surface slopes is another thing to consider. The more uneven your terrain, the harder it is going to be to install the cap. There's also geotechnical considerations, the compaction of the underlying soil. Will it be able to support the cap? And in some areas, you may want to consider the installation of a clean utility corridor for future repairs. If utilities have to be accessed, you may not want future workers going through and into the contaminated media. Next slide, please. When installing the cap, the first thing that you have to start with is a documented design, considering all the factors discussed in the guidance document and all site-specific factors. You need to design to meet the capping objectives. Once you have that in place, now you have a basis for your design, and you need to show that your design is, or your cap is installed according to the design. You should have a knowledgeable contractor, one that understands the techniques that need to be used, and you need to produce as-built figures, or it's really recommended, and conduct surveys. The cap should generally be installed according to the design. As with everything, once you get in the field, there's probably going to be minor deviations or changes to the design. You need to assess them, see if they will impact the functionality of the cap or the effectiveness, and as-built figures and surveys should be used to document how the actual installation of the cap differs from the design. These caps are typically long-term, remedies, and so the cap may be around for 30 years, so the better you document your actual conditions, the easier it's going to be in the future to be able to answer questions when people ask, what is the thickness here? How was this installed? Quality control and inspections throughout the installation of the cap are also going to be important. They're going to show that you are meeting the specs of the cap. This can include the base material preparation, compaction, or surcharging to help prevent differential settlement later on in the cap life. You want to make sure there's no sharp objects protruding from the cap, which may penetrate a clay liner, not a clay liner, but a synthetic liner. You might want to run testing if you're installing a compacted clay cap. Shelby tubes and permeability tests might be appropriate to make sure that you are hitting that 10 to the minus fifth centimeters per second spec. Compaction tests can also be very useful. Integrity tests, smoke tests under some cap types. Additionally, you could take, if you're using a synthetic material, have laboratories test. Make sure that the shear strength is what it's supposed to be. The impermeability is what it's supposed to be. Next question.
Okay, here we go again. Again, this is going to happen probably 4 times today. So again, for the webinar audience, here comes a slide to test your knowledge. But we're going to also test the knowledge of the people again in the room. And the question is, the design of a cap should consider which of the following components? A is stormwater management, B is slip stability, C is compatibility with current and future site uses, or D, all of the above. We have people yelling it out in the audience, and I think that answer is correct. But we're not going to say what that answer is because the webinar audience would probably be upset that we gave them the answer. So we're going to allow them to answer themselves. Again, we're going to give them some time to vote here. Hey, we got 90% voting this time. Joe, did you vote twice? No, okay. 92%, 93, 94. Hey, that's pretty good. That beats our last one. Just to remind everyone, don't try to answer that on the PowerPoint slide. You have to answer it on the pop-up. I think we had some people trying to click on the PowerPoint slide on their computer desk or desktop, and that does not work. You have to pick up on that, answer it on the pop-up. Okay, we have 94%. I think that's pretty darn good. We thank the webinar audience for participating. You can close that, Joe, and we're going to move on. So next slide, and thank you, Howard.
Okay. Now that you've installed your cap, we'll talk about the operation and maintenance of a low permeability cap. First off, routine inspections are going to be important to ensure that the cap is functioning, meeting all of its design goals. These inspections can be include testing for water or vapor transmission, looking for evidence of off-site impacts. Is there increased stormwater runoff, as well as just mechanical problems with the cap? Are there ruts? Are there holes in the cap? The frequency and the techniques that you use in your inspections are going to vary depending on the cap type and setting. As we'll discuss later, a concrete slab can be treated very differently than a compacted clay cap. Parking lot is very different than a low permeability cap with a grass surface on the top. During these inspections, too, you also need to assess for repairs. There's going to be routine repairs that happen through the lifespan of a cap. Small things, if you imagine a asphalt parking lot as a cap, there's going to be potholes. Those potholes need to be patched. The pothole minimizes the thickness of the cap, and you have to address them. There's also likely going to be major repairs through the lifespan of the cap. These are going to be bigger. This would be something, if we go back to the parking lot example, milling and repaving maybe 20% of a parking lot. It's likely going to happen, and these repairs should be considered in your financial assurance. You should plan for them. Small routine things every year, every other year, and make an allowance. You'll never know you probably won't pin it down that it's going to be year 10 that I need to come back and repave a great bulk of my parking lot. Make a good assumption. Next slide, please. It's more to look at for your operation and maintenance of a cap. Your inspections should include assessments of a lot of things. These are just some of them here. Incompatible human activities. Are people going out and digging holes in the cap? Are they gardening? Are people driving heavy vehicles across the cap in places that they're not and creating large ruts that minimize the thickness of the cap? Is there evidence of burrowing animals? You have gophers on site, digging holes through your cap material and ultimately into the contaminated media below and bringing that soil up to the top of the cap. Do you have deep-rooted vegetation that shouldn't be there? Again, puncturing holes through your low permeability cap. Once you poke a hole in it, it's not going to stop water transmission anymore. Surface settlement is an important issue, especially differential settlement. If you're using a clay liner or a synthetic liner, you can generate shearing forces and cause tears if you're not settling evenly across the site. Erosion control, erosion channels forming, desiccation and cracking of a clay layer, or evidence of UV degradation for an exposed membrane, migration of pore water up into the cap, diffusion of contaminants through the cap, vandalism, and perhaps even checking for the presence of gas buildup beneath the cap would be things to consider during your operation and maintenance. Next slide, please. All right, so now I'm going to discuss a couple specific types of low permeability caps, and I'll start off with landfill closure caps. These caps can be very prescriptive according to the regulations that control what's being capped. RCRA, TSCA, NJDEP hazardous waste and solid waste regulations may apply. You should really check those regulations to see if they spell out exactly how your cap needs to be constructed. You may need to run a model. And these cap types will typically involve multiple layers, from a cushioning layer to the clay liner, drainage sand, and a topsoil layer. They're going to be different for every one of these regulations. Next slide, please. Another type of cap that can serve a low permeability function is a structure cap. These could be a lot of different things, starting with building slabs, asphalt parking lots, or other large concrete structures. What's different about this type of cap is that the low permeability layer is usually exposed on the surface. That might mean more frequent inspections and more frequent repairs to the cap material. One thing that's important to consider is the preparation of the subgrade material for structure type caps, because the cap is serving a dual purpose. It is serving as the foundation of a building or the bottom slab of a building, and it's also your cap to prevent direct contact and migration of water or vapors through the cap. So you need to be prepared to have the cap function in both purposes. And one thing to consider too is perhaps the need for vapor mitigation or control underneath the building if that is your low permeability cap. Next slide, please. Okay. Now, not necessarily a type of low permeability cap, but a layer that could be incorporated into low permeability caps is a capillary break. Capillary break is used to prevent the upward migration of pore water and dissolved contamination through the cap material onto the surface of the cap, where that water may evaporate and leave your dissolved contamination behind. Capillary break layers prevent this by stopping that capillary rise. They can be constructed of coarse-grained material so that the interstitial space between the pores is bigger. You don't have that quite a high capillary force, and so you won't get as much of a rise. Or geosynthetics can be used. This type of layer can be incorporated into low permeable or regular permeable caps. It's not specific to low permeability caps. One of the primary concerns for this cap type is, or this layer is hexavalent chromium, where you put a direct contact cap down and you have groundwater level fluctuations rise, and the water comes up through the cap carrying the dissolved phase chromium. Once it evaporates, you can have green and yellow staining as the chrome mineral deposits on the surface of the cap, which then can redissolve or be transported somewhere else outside of your capped area. Now on the figure here, we have, I have some examples of the use of a capillary break layer. The bottom left is granular fill. The two on the right are examples of geocomposites, one with a permeable cap and one with a low permeability cap. Next slide, please.
Wanted to apologize for Howard. We actually made that figure bigger. If you notice, the circles didn't quite line up. We forgot to move the circles. So if you guys were wondering why certain things were circled, Howard had it right. Sorry, Howard, we screwed your slide up. But he had it right.
That's not a problem. That was the secret quiz question. Make sure everybody was paying attention. All right, another, again, not particularly, not necessarily a cap type, but a cap layer that can be incorporated into your overall cap is a vapor barrier. Vapor barriers are what they sound like. They're used to prevent the migration of vapor from underneath the cap to above it. The cap and guidance document focuses on the use of vapor barriers in outdoor settings. The use of vapor barriers for indoor, like we mentioned with structure caps, is covered in the DEP's Vapor Intrusion Technical Guidance document. That should be consulted to make sure your vapor barrier reaches spec and that your cap type for a structure cap complies with this document. These can be typically installed with plastic liners, HDPE or something similar, or with a fluid, I have to read this right off the slide, a fluid-applied rubberized asphalt emulsion, which is like a liquid boot. It's a spray-on application. It's very good in some settings. There are other manufacturers other than liquid boot. This is not a very typical cap type, but again, it may also warrant vapor collection. You know, if you're putting in a vapor barrier, you should look to your need to remove those vapors. Next slide, please. Okay. Shifting over, I'll talk about permeable caps. Same kind of setup. We'll go through some of the commonalities between all permeable cap types, and then we'll discuss a few particular types of permeable caps. In general, a permeable cap is an engineered cap that allows for the exchange of water and soil gas from the subsurface into the above environment. The suitability of permeable caps is discussed in section 3.2 of the guidance document. Didn't want to try to summarize it here. Go into the guidance document and take a look at it. There's a very good discussion that doesn't lend itself to paraphrasing very well. Specific types of permeable caps we'll discuss will be vegetated or landscape caps, evaporation and transpiration caps, and phytoremediation caps. Next slide. Several components of a permeable cap. You can have an optional cover layer. This could be topsoil. All the layers in a permeable cap are going to be permeable. If you put an impermeable layer in there, then you're not going to allow for the transmission of water or vapors. You should include a separation and demarcation layer into your permeable cap. This could be something like a colored geotextile or a construction fence that lets somebody know that you've gone through, you know, if they're digging a hole, you've gone through the clean material, and now you're entering into the contaminated media. You know, clear distinction is very helpful. The finished surface for these caps can be varied. It could be a lot of different things. It could be vegetated. You could just finish it off with gravel. Or pervious pavement, asphalt or concrete can be used. It'll allow your permeable cap to serve as a parking lot, but at the same time allow groundwater recharge into the area and vapor migration out of the area. You got a little figure on the bottom right. Just with an example, a couple layers there of planting beds, gravel path. You've got your landscape fabric liner, that would be your demarcation layer. Next slide. All right, when designing your permeable cap, there's a few things you should consider. The thickness is important. The thickness of the cap has got to be sufficient to, one, protect against direct contact, two, provide ample protection against weathering and erosion, and it's got to be thick enough for the specific site use, both current and what you can reasonably anticipate in the future. You know, if you expect vehicle traffic or heavy vehicles, you may need your cap thicker to be able to withstand rutting. You don't want to put in a 6-inch rut and have it go all the way through your cap. Depth of water or changes in the water balance, mainly applicable if this was an area that had an impermeable surface and now you're giving it a permeable surface, the groundwater table may rise. There's going to be geotechnical requirements. Can your underlying soil handle the capping material? Will it settle? Will it differentially settle? Permeable caps can also incorporate the existing site surface. This could be an example, or it could be used if you have historic fill on the site that's already a little deeper than the top several feet, or for a deeper release of contamination, or for even historic fill, and then somebody comes back later and puts down clean fill. You may have a permeable cap on site already, but you still need to assess it for its effectiveness. These can be used in wetland settings, like Greg said. You don't want to put an impermeable cap in a wetland setting because then groundwater is not going to recharge. And again, you might want to consider a clean corridor for utility access if you do have utilities running through your capped area. Next slide, please. All right, the installation of a permeable cap, again, documented design, and you need to document that the construction conforms with the design, or document any deviations from the design. Surveys and as-built are important. You'll need them for the future to, because again, the cap is likely going to stay around for a long time. So a well-documented installation is important to show exactly what you have on site. There are many different materials that you can use for the installation of a permeable cap. You should check with the Alternative and Clean Fill Guidance document from the DEP 2011 to make sure that the clean fill that you're using conforms with that document. You could use dredge material. There's a lot of different sources that you could use to build up your cap layers. And if your cap is going to incorporate vegetation, you need to establish that vegetation. You should have topsoil on site or on the top that can support vegetative growth. And you need a monitoring plan. It's not just enough to plant the plants. You're going to have to watch that they grow, that they're thriving, and come back periodically to make sure that the plants do remain on site. Next slide, please. A little more O&M. You need to conduct inspections to ensure that the cap thickness is maintained through the lifespan of the cap. You should be looking for things like erosion channels, slope failures, or maintenance of slopes. Do you need to add more soil onto side slopes? Should be looking for burrowing animals and toppled plants, and ruts from vehicle traffic. Burrowing animals, you have to control. Toppled plants, once especially a deep-rooted plant comes down, you're left with a hole in the ground that you might be exposing the underlying contaminated media. You need to go back and refill that hole and maybe recompact in the area. The timing for the inspection should reflect increased use or seasonal changes at the site, and you should continuously check for suitability with the surrounding land uses. It should be something like land around the site being developed and increased stormwater runoff coming onto your site from impermeable surfaces surrounding it. Okay, next slide. I'll start talking about some specific permeable cap types. Just have one slide each. The first one to discuss will be vegetative or landscape caps. These caps can support a wide variety of vegetation. Could be grass, could be trees, could be wetland species or upland species, any type of planting. They will require maintenance to make sure that the vegetative cover is sufficient to prevent erosion. The plants on the top of the cap do serve a very good function in keeping the cap material in one place. They help prevent erosion. Regular inspections for toppled vegetation should be conducted. Exposed roots and underlying soils need to be covered up. Replant or fill those holes as necessary. And again, you have to control any burrowing animals because they're going through your permeable cap and essentially reducing the cover thickness and taking potentially some of the contaminated media from below the cap and bringing it up to the surface. Next slide, please.
Okay, here we go again for the webinar audience, checking your participation. Again, you guys can all play along in the audience here. The question is, inspections of a vegetative cap can stop once the vegetation has been established. How many think that is true? How many think that is false? You guys are pretty good. You're really paying attention. I like that. We'll see how well the webinar audience does. And actually, one kind of interesting part of the webinar, this webinar series, is that we actually know everyone who answered and how many people got it right, which is good. Wow, looks like everyone was on the board. Joe, did you answer the 1% there? Was that you on the 1%? Okay. All right, good. We can close that out. Thank you, everyone, for your participation and a quick response. And take it over, Howard.
Okay. Okay, the second type of permeable cap to talk about is evaporation and transpiration caps. These are used to regulate the percolation of stormwater into the underlying contaminated media, but they don't do it with an impermeable layer. Typically, you conduct a model where you're trying to assess the water balance, and you're trying to balance precipitation against surface runoff, evaporation, and uptake from the plants, transpiration. So really, it serves a similar purpose to a low permeability cap, but all of the material is permeable. When you're conducting the design, you should really be considering your climate, the amount of sunshine that's going to be hitting your site that causes evaporation, the thickness of your cap, and the selected vegetation. Is it grass? Is it trees? What's the anticipated rate of water uptake for each individual plant species? Next slide. And lastly, phytoremediation caps. Very similar to vegetative caps, but the main difference is the plant species itself is expected to conduct remediation, either by immobilizing contaminants or removing them or even destroying them in place. There are many technologies and mechanisms for phytoremediation. They're appropriate for different contaminant classes and types and for different plant species. You know, for an example, sunflower plants are good at uptaking heavy metals. Poplar trees are good at taking up a lot of groundwater and can transpire some VOCs. The ITRC has a lot of good guidance on phytoremediation. You can go to their website and they'll provide you a lot more information about specific classes of phytoremediation and specific types of plants and contaminants for those types of phytoremediation. Next slide. And
Okay, actually what we're going to do real quick is, this isn't in your slide handouts, but what Howard and Greg, or Howard especially, agreed to do was just they had a site where they had a lot of these different cap types, and they were just going to do a quick case study, and then we'll move on to questions. So Howard?
okay. Can everybody still hear me? Okay, this is a site that I worked on with Greg a little while ago. It's the Harrison Avenue landfill, and it's an example where a lot of different capping types were incorporated all in one site. You can see the figure is color coded. Ball fields in purple, a recharge basin in deeper green, low permeability caps in the lighter green, and impermeable surfaces in tan. These are the impermeable surfaces are essentially asphalt caps with sub-base material, no recharge through them. For the most part, the rest of the site, though, was allowed to have recharge. There's some astroturf on the playing fields, but there's a lot of other landscaped areas. The building itself served as an impermeable cap. Most of the waste material, though, was taken out from under the building. So when you have a site that you're looking to cap, you don't have to keep everything to one specific cap type. Another interesting thing about this project was the source of most of the capping material came from a local CDF, a dredge material repository. We were able to get access to that material at a much lower cost because it was just sitting in this depository. Saved a lot of money for the project. And it also had the benefit, too, of opening up the CDF to be able to receive more dredge material, which came from navigational dredging on the Delaware River. Thanks for zooming in. And so, again, we got landscaped areas. Here, let me get the clicker. All surrounding the building. We have our access roads. The preparation and the sub-base material was a little different in those areas. The ball fields, for the most part, are really just permeable caps, soil built up over the underlying material, and then we had this recharge basin in the bottom. That's good. The recharge, yeah, it was like a stormwater basin. We allowed the water to. Oh, I'm sorry. There was a question: was the recharge basin a permeable cap too? And the answer is yes. We were looking for water to infiltrate back through that basin.
All right, we'll open it up to questions then. We have some from the floor. Kathy, you got that one in the back?
Yeah, I apologize, I haven't read the document completely yet, but...
Just one, if we could, when you ask a question, if you could just introduce yourself, what your name is, and...
Dave Russell,
company.
LSRP with AECOM.
Okay, great.
Does
Thank
the
you.
document specify specific thicknesses of the caps? Like a permeable cap, you need 6 inches of topsoil, 12 inches of clean fill before
Nope.
you...
No, it does not specify minimum thicknesses of caps.
Okay, then the second question is, because I believe the presumptive remedy does guidance.
Yep.
Okay. The second question is for existing caps. Is it addressed in the guidance document if an existing cap, an asphalt cap at a site is sufficient? Or is that, again, going to be a professional judgment of the LSRP?
Are you asking whether or not a cap that exists, if the guidance document is say this is no good or it's still good? I think it's professional judgment.
Okay.
Yeah.
Question?
Devang Patel, LSRP. I saw on your slide there was a utilities crossing through your cap.
Yeah.
So that is an easement. How do you handle the easement when you have a soft cap or hard cap on the easement? Have you had any issues with the easement? Township approval is needed for that?
That is a good question. I don't recall the answer to it. Now this wouldn't be for your site utilities. It would be for more municipal utilities that are already there and have the easement. I don't remember what we did on that site. This was a landfill, so the utilities were already going through a landfill. But what we did for our site utilities was to create that clean corridor. But no, that's a good question.
Okay. Other questions?
Sorry.
David Tintola, Chile Environmental, LSRP. I got a general question. If the only remedy for low permeability cap is asphalt parking lot with a stormwater management problem, and you can't discharge it off-site, and the only way you can discharge it is, I guess, a subterranean discharge basin, I'm assuming you're going to need like a general permit or something for that because you don't want to impact the groundwater if it hasn't been impacted?
Yeah, a stormwater permit.
A stormwater permit for
Yep.
that? Okay, that's what I said. Thank you.
Other questions? Okay, Joe, do we have any from the audience? It says, can you address what cap options are available for hexavalent chromium upland sites and whether capillary breaks are necessary or optional depending upon site conditions?
Sure. Well, the capillary break is not a requirement, but it is something that should be assessed. If your cap is anticipated to be well above the groundwater table, and you don't expect seasonal fluctuations or abnormal events to get the groundwater level up into your cap or within the reasonable realm of capillary rise for the underlying material, then you wouldn't need the capillary break layer. But it is something you should consider, especially if you think there is an opportunity that the groundwater will get near to your cap. We do reference some good reference documents for the height of capillary rise for different soil types in the guidance document. You should check that out because it can be very different for sand than from clay. You get a much higher rise. As far as specific cap types, it could be a low permeability or a permeable cap. I think that's really up to the LSRP or the designer's judgment.
Okay. Great. Excellent job. A hand for Howard, presentation. Now to finish this the capping training off, we're going to have Greg come back and talk about sediment caps. However, at the end of this particular presentation, we also have an added training session, and that is for the benefit of a lot of the LSRPs in the webinar audience as well as in the room. It is not mandatory for CECs, but it's kind of a public service announcement, and that is Kirsten will be giving that, and it is on helpful hints for LSRP submittals, which may benefit a lot of people. However, again, I just wanted to say that that is an optional component of our today's training, so feel free, if you do not have the ability to stay and participate in that, you're welcome to leave at the end of our presentation on capping. So, Greg?
All right, thank you. Okay, so we're going to switch gears now and get out of the upland setting, and we're going to move into the aquatic environment. So as the science of sediment capping evolves, they're increasingly being used as a remedial option at hazardous waste sites. The deployment methods in terms of actually delivering the capping materials is advanced, and capping materials are also increasingly using a component of treatment, as I'll talk about later with amended caps. Sediment capping remedies require very careful evaluation due to the dynamic nature of aquatic environments. If you want to think about it in terms of contrasting an upland asphalt cap with a sediment cap, an upland cap would be subject to vehicle traffic, annual precipitation. Those types of factors are typically fairly easily designed for. Sediment caps, by contrast, are going to be, you'll have to deal with changing current and velocities on a daily basis. You could be dealing with tidal cycles. You will very likely be dealing with storm surges. The erosive forces associated with storm surges is something you'll have to consider. Additionally, you'll have to be dealing with potentially ice scour and boating traffic if your water body is near a recreational area. Sediment remedies also have to address multiple trophic level receptors. Your typical upland cap is typically going to be geared towards addressing only the human health aspect of risk. When you're dealing with sediment remedies, there are a host of organisms and receptors that may or may not come into play. You're going to be dealing with the macroinvertebrate community within the sediment itself. You're going to be dealing with fish species in the water column. You may be dealing with birds that eat the fish on the terrestrial side, and finally you may be dealing with human health concerns in terms of humans fishing for the fish that may be contaminated. So your sediment remedy may have to address one or all of these receptor groups. Finally, I just want to make sure everybody understands that your capping remedy must ensure achievement of the remedial action objectives identified for the site, and it must remain protective for as long as the contaminants remain at levels of concern. Next slide. So again, the need for actually any type of remedial action, including sediment remedies, really has to be determined pursuant to the tech regs at 1.16, which requires an evaluation of your ecological component for your site. At this stage, you're identifying the presence of environmentally sensitive natural resources. Those are your habitat types like wetlands and streams and so forth. You're also identifying whether or not your contaminants of concern exceed your ecological screening criteria. And we have a list of those available on our website. If both of those conditions are present, then you're going to move forward into Section 4.8 of the tech regs, which requires a remedial investigation of those ecological receptors. And at this stage, you're really trying to figure out whether or not there's actually a migration pathway on your site linking your contaminants of concern to your environmentally sensitive natural resource. So again, once all three of those conditions are met, then you're moving into the ecological evaluation guidance document, which requires that a risk assessment be done to determine whether or not those contaminants of concern are actually posing an unacceptable risk to the receptors that's present at your site. So again, we don't want people running out and capping their environmentally sensitive areas. You actually have to go through the risk assessment process to determine if a remedy is warranted. There are two types of caps that we're going to cover under the realm of sediment caps. We're going to talk about a conventional cap, which is used to provide a barrier between the impacted sediments and the overlying surface water. And we're going to talk about amended caps, which is a cap designed to provide some component of treatment and or increase the sequestration of contaminants. And this is typically accomplished with the addition of sorptive material to your capping media. Some of the more commonly used sorptive media includes organic carbon, could be zero-valent iron, etc., and I'll cover some more amendments later on in the discussion. Lastly, just like an upland cap, a sediment cap does represent an engineering control, and the institutional controls as well as post-remedial monitoring and maintenance are required. So basically all of the administrative requirements associated with an upland cap would apply to a sediment cap. And again, I'll touch a little bit more on this later. Next slide. Okay, on to design considerations and data needs. Site conditions, more than any other factor, will greatly influence the feasibility of capping in the aquatic environment. It's critical that adequate data exists to effectively design and construct a cap. The level of data needed will be driven by site specifics as well as the complexity of the cap itself. Site characteristics do actually influence all phases of the capping project, namely through design, construction, as well as after the cap is in place with monitoring. EPA has identified 4 broad categories of data needs, namely the physical, sediment, contaminant, as well as land and waterway use needs, and I'll touch briefly on these in the coming slides. Next slide. Okay, these are just some of the physical factors that may influence your capping design. You're going to have to consider hydrodynamics as well as erosion. Your cap has to be resilient to erosion, and this is going to vary depending on the type of river and the water velocities and currents that are present at your particular site. You're going to have to figure out what type of flow you have there. What is the rate of flow? You're going to have to account for 100-year storm events. You don't want to find out after a main storm event that your sand cap that you spent over $1 million to place is now 2 miles downstream. What is the deposition rate of your area? If you put a cap down in a section of a river that has a natural deposition rate, that's a positive. That's going to increase the cap thickness, and that leads to a more protective cap as well as a more durable cap because it's constantly being replenished through the natural deposition process. Water depth can play a critical role and influence the design of your cap. You might be on a water body where there's navigability, and you're going to have large vessels going up and down your river that need a certain amount of depth in order for their hulls not to scrape the bottom of the river. So you're going to have to take that into account. You might not be able to put down a 2-foot cap in that area on top of the native sediments. You might have to first excavate and then place your cap. Water depth also plays a critical role in terms of the ability to actually deliver the amendments or the actual capping material to the sediment media. Applying a 1-foot sand cap over a stream that's 6 foot deep with slow water velocities is fairly easy. Applying a 1-foot sand cap through 30 feet of water column with constant flow, a little bit different. You're going to have to design for that. Slope stability. Is your cap going to be on a slope? How do you figure out your stability of your cap and the ability of the cap to actually stay in place? Now you're going to be talking about geotechnical issues. You're going to have to evaluate for that. What is the sediment bearing capacity of the natural sediment? If you have soft sediments and want to put a 1-foot sand cap on them, you're going to have to account for that. Soft sediments typically require cap placement in thin lifts to help prevent resuspension of the contaminated material. Do you have effective groundwater flux associated with your site? Is groundwater discharging to surface water through the sediments? You're going to have to account for this in your cap design, especially if you're trying to implement a low permeability cap. Next slide. Okay, on to some sediment factors that you're going to have to consider. Bioturbation describes the process of benthic organisms moving sediment as a result of their burrowing and feeding activities. Benthic macroinvertebrates are those critters that actually live in the sediment media itself. This slide here on the left shows an assemblage of various benthic macroinvertebrates. The middle picture is actually a picture of a Ephemeroptera species, which maybe some trout fishermen in the audience might be familiar with. This is the nymph stage of that species. And the picture on the right actually depicts the first foot of the sediment column. And this was taken with a special device called a sediment profiling imaging camera. And as you can see, with the darker sediments on the bottom, they're being mixed and pulled up into the top foot of sediment. So it's critical that your cap thickness must be greater than the effective mixing depth for the cap to remain effective. So if you've got a foot of mixing, you have to put down a minimum of 1 foot of cap because you're going to expect those benthos that recolonize your clean sediment cap to be mixing up to that depth. If you were to put a 6-inch cap over that type of a scenario, you're going to those benthos are going to end up bringing your contaminated media from the 6 to 12-inch increment up into the surface of your cap, and now your cap surface is no longer clean. In terms of benthic community structure, you want your capping material to allow for the recolonization of the macroinvertebrate habitat. The macroinvertebrates in the sediment environment basically form the base of the food chain, and it's essential that they be able to recolonize that area. So sand caps can receive organic matter due to natural deposition, but that may take several years. There's been advancements in actually incorporating capping materials into your sand cap material to actually accelerate the recolonization process. Next slide. Waterway use factors. It's critical that you consider your upgradient background sources if you're intending to place a cap in a river system. The effectiveness of capping can obviously be offset by the continued deposition of contaminated sediments onto the surface of your cap. You have to be aware of this and take that into account if you're considering a capping remedy. You would determine what your upstream capping concentrations are by performing a robust upgradient sampling approach. What type of access does your site afford you? Do you have actual room for staging and processing cap material? Access is not quite as critical for capping as it would be for a dredging remedy, but again, it's an important consideration. Many of our industrial waterways are very developed and there might not be enough room to actually perform a capping remedy. What are the existing site conditions? Do you have piers and bulkheads, such as pictured here, that would perhaps limit the effectiveness or your ability to actually place the capping material where it needs to go? Is your caps going to be in a navigational area that receives maintenance dredging? You know, we don't want to find out that your 2-foot sand cap has just been dredged by the Army Corps 2 years later. Is your site subject to recreational use? If you're going to implement a cap that has a geotextile, perhaps at 6 inches or a foot beneath some clean material, is your area going to be subject to recreational boating where you might have anchors digging into your cap? Again, something you're going to have to consider in your cap design. Next slide. Contaminant factors to consider. You know, what's the horizontal and vertical extent of your contamination? That's obviously going to help dictate what your cap boundaries are. The vertical extent of the contamination may play a major role in determining your cap's thickness, especially if you're utilizing an amended cap with sorptive material to treat contaminated pore water. The type of contamination that you have present at your site is also going to dictate the design of your cap. You know, you're dealing with a relatively mobile contaminant like a VOC, or you're dealing with contaminants that tend to bind tightly to the sediment, such as PCBs and pesticides. You know, do you have NAPLs present in the sediment? Coal tar sites, that's a very typical type of contaminant. If you do have NAPLs present, you might have to deal with the process of ebullition, which is the transport of contaminants through gas generation and their upward movement to the cap surface. If you have that condition at your site and you're trying to implement a low permeability cap, that gas can actually break through the cap surface and could lead to the formation of sheens above your cap. You know, if that were to happen, your cap would be considered a breach in integrity and would require repair. We obviously want to try and avoid that situation. Next slide. So again, the two types of caps that we cover in the document are conventional caps and amended caps, and I'll just cover a few things here with conventional caps. These types of caps are designed to actually isolate the contaminated sediments from the water column and prevent their suspension and transport down gradient, and they're also designed to actually isolate the contamination from the local biota. These caps are typically constructed of sand because it's readily available and very easy to deploy. Any type of capping material used in the aquatic environment has to be tested pursuant to our alternative clean fill guidance document. Some things to consider, you know, what's the grain size and geotechnical parameters of your cap? You're going to have to consider that in terms of figuring out whether or not that material is suitable for long-term stability. Your cap may include the installation of a boundary layer, such as a geotextile, or armoring layers to prevent erosion, such as large stone or riprap. So again, the need for these features are driven by site specifics and up to the designer to determine. Next slide. So amended caps actually have all the benefits of a conventional cap, but they include additional layers to actually prevent contaminant migration. And they're typically employed to address highly mobile contaminants such as VOCs, but can also be used to sequester contaminants such as PCBs and PAHs, which actually partition into the pore water of the sediment. A word of caution is they may not be appropriate to use where source areas have not been remediated or where groundwater flux rates are high. Some of the amendments typically employed in caps include materials such as granular activated carbon, and they are commercially available through companies such as Sedimite and Aquagate. Organoclays are also frequently used, as well as zero-valent ion and reactive core mats. These are increasingly being used on some of our larger industrial sites where sediment capping is being employed. And again, it's the site specifics that really drive the ultimate remedy. So you're going to have to consider what your contaminant suite is and then design your amendment around that. Bench scale studies are typically needed to accompany an amended cap remedy, and these help determine the actual amount of reactive media required to be put into the cap in proportion to other components, and to actually help estimate the lifespan of the reactive media. And US EPA has put out a very useful document on the use of amendments for in-situ remediation of Superfund sites, and we actually provide a hyperlink to that document from our guidance document. Next slide.
Okay. Actually, yeah, we have another test, I think. There we are, test our knowledge. And this is, again, to check on our webinar audience and their participation in paying attention. But we also test our in-house audience. And the question is, sediment cap thickness needs to be equal to or greater than the bioturbation depth. And how many think that is true? How many think that is false? Well, actually, I think the answer probably is Greg's not going to let me know. But the idea is I think our in-house audience had it correct. Again, they are excelling and showing us that they are paying attention, and I'm sure Santa Claus is going to be good to them this year. Let's check on our webinar audience. Wow, we have 100%. That's pretty good. So Joe definitely participated on that one, or we would not. Okay. Well, thank you guys so much. I really appreciate your patience in implementing this. I think it will pay off in the future. So we'll return to our previously scheduled program. Greg?
Okay. Thanks, George. All right. Should come as no surprise, monitoring is going to be required as a component of any sediment cap because, again, a cap is not a permanent remedy. US EPA states that monitoring should be required as any sediment remedial cap. The main objective of monitoring is to ensure that the cap is placed as intended and is performing its basic function in meeting your remedial action objectives. Monitoring is critical as sediment caps are located, again, in dynamic environments and are subject to forces that have the potential to undermine their integrity to a much higher degree than upland caps. It's important to establish baseline data against which measure remedy effectiveness. And if this data is missing, it may need to be collected during the design phase of your capping project. An example of that could be if you have PCE contaminated groundwater discharging to surface water and you wanted to incorporate an amendment such as organic carbon to help capture and absorb that PCE, you would typically evaluate the effectiveness of that on the post-remedial side by collecting pore water data. Well, you'd most certainly want to have some pre-existing, pre-remedial pore water data to show how effective your amendment is at actually reducing your pore water concentrations. Monitoring can be thought of taking place during 3 phases. It could take place during construction. We have performance monitoring and remedial goal or long-term monitoring, and I'll touch on all those in the next few slides. So construction monitoring is really geared towards answering the question, is the cap constructed as designed? If the design called for the placement of a 1-foot cap, construction monitoring could consist of either sediment coring or bathymetry surveys to ensure that you've actually met that design thickness and to ensure that that cap thickness is present over the entire area. It may also include monitoring during cap placement to monitor perhaps suspended solids. When you're walking in the water and you're dealing with the bottom of the sediments, you can disturb that contaminated material. You're going to want to you're going to control that. That can be done through the installation of silt curtains. Again, the need for that is going to really be site dependent. It's something you got to consider. Next slide. Performance monitoring. This is designed to answer the question, is the remedy mechanism actually performing as designed? So again, going back to our 1-foot cap example, is the capping material remaining in place after significant storm events? Again, this could be assessed through sediment coring. If we're dealing with a cap that was put in place to reduce their surface concentrations, you could test that through sediment sampling. If it's an amended cap, again, we could test the effectiveness in terms of performance by conducting pore water sampling. Next slide. Remedial goal or long-term monitoring. Is the remedy actually achieving risk reduction? Long-term monitoring actually provides an assessment as to whether or not your remedial action is achieving your remedial action objectives. We have both direct and indirect measurements. A direct measurement of risk reduction could be if you had fish tissue concentrations above levels for safe consumption. On the post-remedy side of things, did those concentrations actually decrease to where they're safe to eat? An indirect measurement could be sampling the media. You can collect surface water samples. You can collect sediment samples. You can collect pore water samples. That's going to tell you whether or not you're meeting your long-term objectives. So that basically covers monitoring. Next slide. Institutional controls. A sediment cap, like any other engineering control, must remain intact to be protective for as long as the contaminants remain at concentrations of concern. Thus, the need for monitoring, as just discussed. To ensure that monitoring takes place, the DEP will require that a soil remediation permit is obtained for all sediment caps. The soil remediation permit will contain a monitoring plan to ensure that the cap remains protective, a deed notice to ensure that these areas are not disturbed in the future, as well as a financial assurance. I'm not going to go into the details of the soil remediation permit, but they can be found in the Department's 2010 guidance document titled Remedial Action Permits for Soils Guidance. Next slide. Okay, deed notices. There's 3 scenarios I wanted to go over relative to sediment capping. If the sediment cap is actually located within the property boundary of a site, which means that that particular site has riparian rights that extend out into the water and establishes lot and blocks, then a deed notice can be established pursuant to Section 7.2b1 of the Tech Regs. If your cap boundary extends onto another entity's property and they have riparian rights, then a deed notice can be established pursuant to the same citation, but the owner of that site must be willing to accept the deed notice. And the last scenario here, which may come into play on larger water bodies, if the cap boundary extends to areas of the stream or river that are actually owned by the state of New Jersey and no deed for the property exists, then documents can be prepared in lieu of a deed notice pursuant to 7.2b2 in which case the state of New Jersey must be willing to accept the equivalent of a deed notice. So that wraps up sediment capping as well as the overall presentation today, and I'd be happy to take any questions.
Okay, we'll take some questions if there are any from the audience. Seeing none, we'll open up the webinar audience if there's any questions. Oh, we do have one from the, well, we got 2, right?
Divang Patel, LSRP. If we have a historic fill near the water bodies, surface water bodies, and obviously there's a potential for runoff and maybe contact of water with the historic fill. Assuming there's no runoff, we have the vegetative cap that prevents the runoff. How do you handle with the water body that is close to the historic fill material? How do we comply with that if it's with the potential impact in a monitoring perspective?
Well, a historic fill is usually associated with a regional filling event. So it's typically the rare site where you have historic fill present only on your particular site that's impacting a water body. Historic fill does have to be evaluated in terms of whether or not those contaminants are leaching into the creek or eroding into the water body, and you would compare those data to our screening criteria. If it was truly a regional event, then similar fill typically be present upsite, and the contamination that's entering the water body, both at your site and upgrading it, would be of similar quality. So in that case, professional judgment would come into play as to whether or not your particular site is impacting the water body at levels above what I would consider ambient contamination. So you have to address it, but we do take into account that if it's historic fill, it's usually a regional type of issue, and then we'd have to assess whether or not a remediation would actually benefit the environment or not.
A question in the back?
I'm Mike Infanger with Site and Remediation Program, and I noticed you said that the state of New Jersey has to approve if the contamination requires a cap. But who at the state approves that? Where do the LSRPs go to get this approval?
Yeah, that's a good question. I mean, we haven't, this is the first time this guidance has spoken to this issue, so we don't have any test cases, if you will, where we've already gone through the process where I could give you a definitive answer as to what particular office within SRP would actually answer that, would be in charge with approving that remedy. But, I think as it moves up the chain, as it moves up the management chain, ultimately we're going to have to decide whether or not the remedy is protective. I think some of the work being done on the Passaic River, which is obviously a high priority case, we're going to be tackling that issue. So I don't have a definitive answer for you at that point in terms of who is actually making that determination.
Would a land use, the wetlands group, would they be involved?
They might be involved in terms of the permitting of the remedy, but I think the decision regarding whether or not the proposed remedy is actually protective, both long-term and short-term, that would fall back into SRP's decision.
Okay, let's take a couple quick ones from the web audience. This one says, it's from Robert. How often are inspection of sediment caps required?
I don't think there's any type of rule of thumb. Again, it's going to be site-specific. I think a sediment cap placed in a very small water body with very little flow, would warrant fewer inspections than a similar cap placed in a high-energy environment that may deal with boat traffic, may deal with recreational use, or may be subject to really flash flooding. So again, it's going to be site-specific.
Okay. Next one from Christopher. What if the owner of the neighboring property of a proposed sediment cap does not accept a deed notice to be placed on their property?
I don't think that's any different than what we deal with on the upland side of things. I think if you have contamination that's associated with a site discharge and it goes on to someone else's property, that person has the right to demand an unrestricted use cleanup. I don't think, I don't think a person that's associated, a site that has a discharge that goes on to someone else's property gets to dictate what type of cleanup occurs in an off-site setting.
Okay. It also is the same answer for the next one there, Joe. So next question. Can we please have a 5-minute restroom break prior to the optional session? Carol, that is an excellent question. Perhaps we'll tell you when it's coming up, and you can sprint. We'll take that into consideration when designing the overall program for the webinar, but thank you for that feedback. Next question. Are there specific requirements for frequency of verification sampling of sediment caps? I think you just talked about that, so that's addressed. And Carol said thank you. All right, Carol, we'll make sure to, that's on our list. We have someone taking notes right now. Any other questions in the web or in the house audience? We do not. So at this point, I'd like to thank our two presenters. You guys did an excellent job. And I would also ask everyone to make sure that they, if they are in the situation to do consult the guidance, as well as the presentation today. At some point, we will post this up on the web as an archived training session, and you will be able to access that. So again, thank you guys so much. As noted previously, what we are going to do now is kind of a public service announcement that we are fortunate to have Kirsten Pointenhand, who is the Chief of Case Assignment and Initial Notice, commonly called as BCANE. So, nope, we're just going to start, just for the help of everyone here. Did anyone in the audience need a break? This should only take about 10 minutes, so I thought we would just power through it. Okay, everyone's good with that. Okay, Kirsten?
Good morning. I'm going to talk about some helpful hints for LSRP submissions. And first, I'd like to say the quality of the submissions has improved dramatically in the last couple years. So this presentation is really just going to focus on the issues that we're still seeing with incoming submissions. When you submit something, we don't want to receive it in piecemeal. All parts of the submission should be put together. The forms should be placed on top of the submission. You're not doing us any favors by embedding the form in the remedial phase document because often it gets overlooked and then a deficiency letter will go out. You need to include a receptor evaluation when you're submitting all remedial phase reports unless you're going to issue an unrestricted use RAO within 1 year of the trigger date. There's been some confusion on that. We've had LSRPs submit an initial receptor evaluation and then complete the remediation within a year from submission of that initial receptor evaluation, and they felt that they didn't need to submit an updated receptor evaluation when they submitted the RAO package. And the requirement to not complete the receptor evaluation when you issue an unrestricted use RAO within 1 year, the RAO needs to be filed with the department within that year time. You can't just complete the remediation in a year and then give us everything, you know, in 18 months. We would then expect to see the receptor evaluation. If there's unusual circumstances that applies to your submission, please note that in a cover letter and place that on top of the forms. And that would include like cases that have multiple PIs, multiple deed notices. Make sure you include a CD with your submission and make sure it's attached well to the document and labeled. You know, sometimes people submit CDs and it's just rubber banded to the report. We get hundreds of pieces of mail a day and things do slip out. So, you know, it's critical that you make sure it's properly attached and that it's labeled should it, you know, separate from the submission. Next slide. I'm going to talk a little bit about the electronic submittals, the CDs. As I said, clearly name the CD. Organize your files by document type, like your case inventory document, your report, your lab data. And keep in mind that the file size must be under 150 megabytes. If it's too large, break it down into separate files such as the report text, figures, and tables. Next slide. Form completeness and administrative issues that we're seeing with submissions include you need to accurately put the block and lot on the form and the municipality, and if an underground storage tank registration needs to be updated, that needs to be done before you make the submission. The form should include all incident numbers that are applicable for that submission. If you're working on a case where you've had multiple discharges, you have multiple incidents, and you've asked us to bifurcate those incidents into two separate cases, do not reference all the incident numbers if they're in a different activity, because that just causes confusion. We do recognize that sometimes you're going to put all the AOCs that you're working on in one submission, but if you've asked us to break apart that case, you're going to need to submit that document twice, once with the case number for the case that you asked us to pull out, and once with the case number that is in the other activity. Make sure the forms include all appropriate PI numbers, ISRA trigger numbers, closure numbers. All forms need to be signed by the LSRP and the party that's completing the remediation. and also include an email address for the party that's completing the remediation. Next slide. I went over that one. Next slide. Remedial phase completeness. There's been some confusion with submissions for RIs. We don't want an RI report and an RI form if the RI is not complete for all the areas of concern in that submission. So that's critical. We don't want to look at something where the RI isn't complete. You must submit a CEA WRA fact sheet form for cases that have groundwater contamination when the RI is completed. And remedial action permit applications require submittal of a corresponding remedial action report and a remedial action form. One of the major issues that we see with remedial action permits is often the LSRP will make the submission directly to the permitting group, thinking that that might expedite the turnaround of the permit. That only causes unnecessary delays because those permits come in with revenue, and the revenue needs to be processed by my office. And, you know, sometimes I'm seeing that checks are coming over and I have no idea what the check is for, and then through a little investigative work we find out it's because it's a fee for a permit. The permit went to the permitting group. They started running with it, but just sent the check to my office without the form, and the permit really can't be issued until that fee is paid and is in our system. So those documents need to come to case assignment. Next slide. RAO completeness. Before issuing an RAO, all fees need to be paid, all permits need to be obtained when applicable, and if you're dealing with a CEA removal or a D notice removal, that must be completed before you issue the RAO. Only include the incident number on the RAO if all associated media are remediated. And lastly, once the RAO is issued, it should not be modified unless it's done through an amendment process with our Bureau of Inspection and Review. And that's it. Any questions?
Great. Thank you very much, Kirsten. Questions within the audience? Oh, okay.
I'm Judy Byard with the DEP. I have a comment because I review these documents. What happens is sometimes these are, well, quite often the documents are administratively deficient, and sometimes additional fees, annual fees will accrue because of it, especially if we send emails or deficiency letters and the responses are piecemeal. So everybody needs to keep that in mind to move things along and to make it fair for the responsible party that they don't have to pay additional annual fees. And then the other comment I have is with the CDs. Sometimes people break out the CDs into like 50 files, and that's not necessary. Plus, it probably is a very time-consuming process for the LSRPs and the contractors. And as Kirsten said, if it needs to be broken out, it should just be for the report and lab data, that sort of thing, not 50 files or more.
Okay. Great. Excellent comment. Thank you for clarification. Got one back here, and then I'll get you.
Regarding recording the historical documentation for your submittals when you're submitting a remedial investigation or remedial action, the historical documents, if you were recently retained, are, I guess you can say, either gathered from the department through an open file review or through contractors you know that the department has already or may not have. Are we supposed to redigitize them for the department and then submit them?
Yeah.
Okay.
Yeah, unfortunately.
However, so whatever documents we reviewed, we're going to put in.
Whatever documents you use to make the decision should be included electronically on the
Okay.
list.
All right, thank you.
I think one of the issues there, it's very difficult for us to find those documents if we had to. That would hold up your submission, so it's really to your benefit to have those within yours.
Thank you.
Okay, question here?
Kirsten, in one of the documents or in the forms, we have to check the box saying is the previously NFA audios issued for the specific PI number. Obviously, we can check audio, but we don't know when the department has issued NFA. Sometimes it's difficult to answer that question. We sometimes don't have the history of NFA. And if we answer yes, it's issued, we have to include in the submission NFA letter. Is there any easy way to get that information without going through the 10 weeks of Oprah
So you're talking
review
about
process?
like an ISRA site where your ultimate goal is to issue an entire site RAO?
No, just in general, if I'm doing a USD work on it could be a ISRA site previously, or it could be just a USD site, 92, somebody pulled the tanks out, replaced it with new tanks.
Right.
We're pulling in new tanks, and hoping that in 90s they close the case and there's NFA. But we don't have the access to the NFA letter. We're just specifically hired to do one area of concern, maybe one tank, but if there might be a previously NFA issued for the other tank activities,
Right.
is that we have to go and get it from the department, and it's just difficult for us to get that
Yeah,
in time.
if that case number is linked to the case that you're working on, then yes, unfortunately, you're going to have to go through Oprah and get a copy of that NFA to show that that incident was closed out. If it was a separate case at some point in time, we don't care about it. We're only caring about what you're working on, the case you're working on. So if it involves, 5 incidents, 2 were previously closed by the department with an NFA, we would want to see those 2 NFAs, and then we'll just follow the other 3 AOCs by the RAOs that you will be issuing.
I think then that question needs to be revised to make it clear, because when we are working on a specific one area of concern, let's assume gas station is perfect example, 10 tanks, 5 tanks were removed and replaced, and there we find abandoned tanks while we're doing some due diligence. Those tanks are pulled out, we give you NFA or RAO letter for that.
Right.
Do I need to get the NFA letter for the previously removed tanks and resubmit that? That's I'm trying to figure out.
I don't think
But
so,
it's not
because
associated with the
that
link.
would have been in a separate case.
Right, so
You know,
I think the
will-
question says that has this site received the NFA letter previously? If yes, then include the NFA letter, or have you included those NFA letters?
Okay.
And that's just always difficult to answer that question.
Right. I don't think you need to do that.
Okay.
I will speak to Myrna. Are you coming to the CDP STRAG meeting next week?
I'm not invited, but I will be willing to.
Well, I'll get back to you then, but I really don't think we want you to do a whole history of everything that occurred at that site over time. We just care about what you're handling.
I just want to clarify one thing. I'm Elaine Dewan. I work with Kirsten all the time. Our previous PASI form did have in the SI section all the stuff about, kind of accounting for all the us that were ever at the site. We removed that from the SI section and put it in the preliminary assessment section for this particular reason, because if you were just working on a tank or a discharge, pursuant to the underground storage tank rule, that is your case. It was not really fair making you do like a mini PA when you're only doing an SI. So, for a full site, where you do a PA, there you have to provide your documentation, but just for doing an SI or an RI for a tank, an individual tank or individual discharge, that is not required.
Thank you.
Thanks, Elaine.
Question over here?
Hi. Yeah, my question has to actually do with NJDEP Online. And I've had this problem, and other people I've had, is that when you go to retain on NJDEP Online, there's often not an appropriate activity code associated with the NJDEP Online files. And I've had to go to BUST or to different people to have the activity code assigned. Is there an appropriate, a best place to go to fix that issue?
Well, what creates the activity is for a discharge, the submission of a confirmed discharge notification form. When we receive that form, we create the activity. For an ISRA case, it's the submission of a GIN. If you're closing a regulated tank that's not out of compliance, you're not going to find an activity. You're just going to have to link to that PI.
There are cases where guidance, for example, historic fill guidance says if there's an existing PI at a site, you don't send in a discharge confirmation notice. But if the existing PI's case, if it was a tank, has been closed, you can't retain.
Well, that would be another unique situation because you're not calling in the discharge to the hotline, and if your only AOC is historic fill, you are going to run into that problem.
Right. And my question is, who fixes it? Who should we contact? Should it be BK? Should it be somebody else? Because this is a mole. I mean, I've had this several times.
Well, you know, we've handled it in two ways. Some LSRPs will call us when they're ready to make their first submission, and we'll set up a PI number for them with an activity and call them back and provide that information. If you don't want to do it that way, you can submit the forms and not reference a PI number and an activity number if in fact no PI exists for that site. And then in a cover letter indicating you're only dealing with historic fill, that there isn't a PI or an activity for you to link your retention to, and then we can set it up at that time and then pick up the phone and call you.
Okay, let's take a couple from the webinar audience. And actually, I'm going to have to apologize to Carol because I just reread her comment. I thought she meant as far as the optional questions that we're asking. She meant to take a break between these two sessions. So Carol's probably not happy with me as the moderator, and I apologize to her. I misread that. So everyone in here is a little probably waiting for the break. Anyway, we're going to ask this question: should remedial action permits for soil go in as an RER, REW? Typically, the cap is already installed by the time we submit the RER, but we need approval for the permit. Can we submit them as an RER with a request for permit approved? Or permit, yeah, approval.
I don't see any reason why they can't do it in that manner.
Okay. So the answer to that was yes. Thank you. Here's one from Mindy. If you have a initial PI number for several parcels of property that was subdivided and as such has been given separate PIs, do you need to list the primary PI number on the submissions? If yes, what submittals?
So, well, my question is, are we managing the case under one of those several PIs? Are we managing the case under only one of those several PIs?
Well, let's assume the answer to that is yes. What would they do?
Then they only need to reference the PI number that
the case
the
in
work
question.
is under, yes.
Okay. We're going to hope that was sufficient for that. Next was from Gary. At legacy sites with 10s or say 100 or more AOCs, do you really think what you're saying is realistic? I think was that what Elaine had talked about earlier? If you're working on a tank or a specific discharge or AOC, would you need to do all of, I think you were talking about submitting all the historic information?
Right.
So maybe they're asking, is that realistic to get all that information for the entire site and submit it? Seems to me what Elaine was talking about, if it was a specific AOC or discharge, you would not have to do that.
I would look at whatever the PA-SI guidance says on this, because the PA-SI guidance was developed with ISRA in mind and all the requirements under the ISRA statute and rule. So I am not intimately familiar with the PASI guidance, but that's what you have to follow to fill out your PASI form.
That,
Right.
Okay, we have a comment from the audience. Good.
regarding that matter, though, if you have an old UST case from like 1995 or 1993, and you're going to provide that they were technically deficient from, like, say, the last, one of these cases that they did nothing for 10 years, and then all of a sudden you started sending nasty letters, and then they finally did something in 2012, all that information was prior to 1998, and so it may be available or may not be available. That's why I said in piecemeal. So maybe that's what they're referencing, because if you're dealing with a legacy UST case where someone had an improper closure or whatever, and then didn't provide supplemental information till they finally got one of those lovely letters, the exact content of that historical information may or may not be beneficial to any party. You understand what I mean? Because if that historical information was way old, it's not going to be it'll be used to us, so I guess it could be used for you. So it's kind of a gray area.
I mean, if you're using it to make your decision, then it has to be included.
Right.
Okay.
You know, if they were non-compliant and you're going in there 15 years later and pretty much doing everything from the get-go, there's no reason to put the historic information in there.
Okay. Thank
Actually,
you.
looking at a second comment from that Gary submitted, it says, we are opining on all AOCs at ISRA sites because of the order of magnitude rule. Do
Right.
you understand?
So I think he answered his own question.
Okay. Appreciate that, Gary. Caitlin has another question. It says, the CEA form asks if you are establishing a CEA and submitting a permit application. If you're just submitting to accompany the RI submission, will this form be incomplete because the permit is not being submitted?
No.
No.
The whole purpose of that question is to figure out who will be processing the CEA. So the CEA for RIs go in one direction.
Right.
The CEAs for the permit go with the permit. So there should be one or the other.
Okay. So again, that depends how the department is processing the CEA.
Right.
Okay, I think that's it. Oh, I'm going to need a microphone. Kathy's in back there.
Well, it's a little vague in the rules, but there's time frames of when to apply for a permit for a CEA. So if you're not at that point, then you would do the CEA with the RI.
Right, right, exactly.
Okay, and that's on any other questions from the audience? Seeing none, we will close.
There's one more from online.
Someone snuck one in there at the very end. We'll take it. If you're submitting a CEA for a site where a source remediation is not yet completed, is it still required to complete fate and transport calculations at that time? That's a good question. I don't think any of us understand.
Yeah.
Oh. We have someone in the back that understands that?
No, it's acceptable to submit it as indeterminate and not do the fate and effect transport. If you're at the RI phase and you're not, you can't
Okay,
really predict.
I see. Those calculations are just for the duration of the CEA, correct? Okay. All right. So now we're really going to close today's presentation. I certainly appreciate everyone in the House audience as well as the webinar audience, and thank our presenters. Again, all this information will be posted on the website. I would ask you to remember to fill out the forms. I was remiss to identify the evaluation forms in the beginning, but we greatly appreciate your feedback, and thank you so much for your participation.